I'm Jesselyn, and I'm from Hackster, and it's my honor to introduce you to our presenter today, Clay Hine. Um, Clay has held roles in sales, marketing, and business development at a variety of semiconductor companies over the past 25 years. Prior to that, Clay held roles in engineering at a company developing microwave systems in the space and defense industry. He has been with Nordic Semiconductor since 2015, most recently as a business development manager focusing on growing Nordic's engagement in several key vertical markets. Clay has a Bachelor of Science degree in electrical engineering from the University of Illinois. So today, Clay, please help me welcome Clay. He'll be presenting smart agriculture and Nordic and wireless IoT today. Just quick housekeeping. If you have any questions, you can use the chat, but we are also going to be using the Q&A button at the bottom of the screen. So without further ado, Clay, please take it away.
Great. Thanks so much. Good to be here with you all today. As you heard, I'm with Nordic Semiconductor. My plan here is to go through kind of a brief overview of Nordic. That'll only take a couple minutes for those of you who aren't familiar with Nordic. And then I'll kind of jump into some background on the smart agriculture market and how it formed and what smart agriculture means, what it means relative to IoT and wireless IoT, and then how Nordic fits in the scheme of all that. Feel free to ask questions through the Q&A, through chat. I probably won't be looking at chat, but our Hackster friends will. So as questions come up, we can answer them real time or at the end if that's more appropriate. And I will launch right in. Nordic Semiconductor is a semiconductor company that's been around since 1983. We were based in Norway, in Trondheim, Norway, which is the third largest city in Norway, kind of a tech hub in that area. Since we started, Nordic has always focused on ultra low power wireless technologies. In the 80s and 90s, it was very focused on sub-gigahertz. As we went into the 2000s, Nordic developed a proprietary 2.4 gigahertz solution that was low cost, low power consumption, low latency, and it found its way into wireless mice and keyboards. If you are sitting at your desk and have a computer and have a dongle that connects a wireless mouse or keyboard to it, that is almost certainly Nordic's proprietary 2.4 gigahertz protocol. With that, we worked with Nokia to develop a new solution at the time that Nokia had the concept for, looking more broadly than just Bluetooth audio headsets, which was the state of Bluetooth at the time, to other things that might connect to phones that would also require low power, low latency. And we developed a protocol that eventually became adopted by the Bluetooth Special Interest Group called Bluetooth Low Energy. Since then, Nordic has launched the standalone Bluetooth Low Energy radio, and then we're on our fourth generation of wireless SoCs that include ARM core processors, flash RAM, lots of peripherals, and support Bluetooth Low Energy along with lots of other protocols. We've also since expanded that initial IoT offering of Bluetooth Low Energy and proprietary 2.4 gigahertz to include lots of other protocols and support lots of global applications and customers. And I'll talk about some of these protocols as I go through this and talk about how they relate to wireless IoT and smart agriculture. Today, as I said, Nordic has a whole suite of what we refer to as short-range SoCs that support some of the shorter range wireless protocols like Bluetooth Low Energy, Matter, Thread, Zigbee, a few other ones. We actually have a Wi-Fi solution we launched recently that's again focused on IoT, low power, lower data rate relative to typical Wi-Fi data rates. And we've expanded into longer range solutions that include some of the cellular IoT protocols and a couple of other interesting services. We've added some other technologies in terms of chips and also in terms of resources like cloud services that sort of round out our portfolio to make it very accessible for lots of different applications. So you might be wondering, what does Nordic have to do with smart agriculture? To kick that off, I'll give you just a bit of a background on smart agriculture. As you might have heard, my background is in electrical engineering. I've been with chip companies for a few decades, did R&D engineering before that relative to RF and antennas. So I don't have a whole lot of background in smart agriculture. At Nordic, I've been in business development for a few years. And when I adopted smart agriculture as one of the vertical markets I was responsible for, I spent a lot of time doing research on it. And it is quite fascinating looking at the history of agriculture and how our technology of today, specifically with Nordic, how our RFSoC technology can positively impact agriculture, not just agriculture, but as you'll see as I go through this, some of the issues with agriculture that really affect all of us. First of all, what is smart agriculture? It's just technologies, general technologies, and implementations of those technologies that can enable farms to optimize operation and minimize resources, including labor resources and human interaction. Uh, Optimizing yield and making farms as efficient as possible so you get the most crop yield out of the smallest amount of space. It's a relatively emerging market. There's applications that probably a lot of us have seen for smart agriculture. There are a whole lot more applications, though, yet to come going forward that I'll talk about in here. And just by terms of in the way of definitions, as I've done research on this, you'll hear people say smart farming, smart agriculture, precision farming. Those all mean roughly the same thing. Some people have a little different shading to each of those depending on the context they're used, but they all basically mean the same thing. They all refer to these smart agriculture technologies and implementations that I mentioned. Just by way of a short history lesson, I'll try to condense 10,000 years into just a minute. The first, what is generally referred to as the first agricultural revolution, again, about 10,000 years ago, was shifting from hunter-gatherers, individuals, families just kind of subsisting, went into farming and herding for communities. It took a long time for what we refer to as the second agricultural revolution to come around in the 18th century. That was focused on crop rotation. We've all seen and heard about some of the benefits of specific crop rotations over the years or over the course of a year, and then selective breeding of livestock. Livestock care is kind of pulled under the umbrella of smart agriculture for a variety of reasons, and I'll mention those later. The third agricultural revolution is usually looked at as post-World War II, when we got more into selective plant breeding, which included genetic modification of seeds. We don't have a whole lot to do with that in the semiconductor world, but that also fell into or included mechanization of equipment. So a lot more automation, more machinery type implementations that serviced agriculture. Today, some folks will say we're going through the fourth agricultural revolution to look to even gain more efficiency out of the way we implement agricultural techniques, and we call that smart agriculture. Just to give you an idea for what the agriculture market looks like, today there are roughly 570 million farms around the entire world. The global agricultural market last year was about $13.5 trillion, expected to increase by about 50% over the next 4 years. So it's a dramatically growing market. 17% of the world's GDP is from farming. Agriculture employs about 25% of the global workforce when you look at all of the different aspects to agriculture. A couple interesting things here that start to introduce some of the issues we see with agriculture today. Today, 38% of the world's land is used for agriculture. Now, about a third of that 38% is actually for crops that are grown that people eat. The other 2/3 is for livestock and crops grown that feed livestock. When you look at that graph at the bottom, you can kind of see how the world's land is divided up, including on the far right, land that's not really usable, land that's either covered with glaciers or it's deserts, salt flats, areas that can't really be used for habitation or farming. You can see in there that tiny little sliver of less than 1% is where people live. There's a whole bunch in there that is used for farming. As I said, on the far right, you see farming for livestock and farming for crops that feed people. And then there's a bunch of the planet still that is forested, that serves a pretty important purpose in keeping the planet alive. Kind of the end product of those last two bullets, though, is that there's not really any significant amounts of land left today to go farm. So as we look to increase the output of agriculture and of the agriculture industry, farming more land is not really a broadly practical option today. That's where smart agriculture comes in. Just as a kind of background to that, today on the planet, of the roughly 7 to 8 billion people on the planet, over 1 billion people lack sufficient access to sufficient food. By 2050, that problem gets a whole lot worse with over 9 billion people, by some estimates, or even more, on the earth. And if you kind of take those two factors into account, you come up with we need to grow twice as much food in the next 25 years to provide sufficient food access to what the expected population of the earth will be. As I mentioned in that last slide, farming more land is not really a practical option. We don't have a whole lot more land that we can go farm. One of the other factors involved in some of the disparity in distributing agriculture and in people having access to foods grown today is that as much as 25% of the food produced today isn't eaten, it's subject to spoilage. So looking at all those factors, looking at where we're going, the planet needs technologies like Smart Ag and the suite of technologies that Smart Ag can encompass to help grow and distribute food more efficiently. Smart agriculture can help drive enhanced efficiency, improve yields of agriculture, can help lower costs of producing agriculture and farming costs, can help minimize some of those distribution issues that I mentioned by doing things like growing food where it's needed and implementing wireless IoT to enable less spoilage. And also, as we're doing all this, something I haven't mentioned is making sure we minimize any negative environmental impact from farming. Lots of things we do have a negative environmental impact. Certainly doing more for farming could exacerbate that unless we're very purposeful about how we implement some of these new technologies. When we look at all of those factors on the left, and I'll mention it, I'll talk more specifically about this as I go on, but all of those different factors are supported in a positive way by wireless IoT. Just as an example, today on farms, and this slide is actually a year or two old, there's about 2 billion wireless sensors. Over the next 10 years, we expect that number to grow by 10x, all in support of Smart Ag and some of these specific aspects of Smart Ag that you see on the left. I'll talk about a couple market dynamics and then launch into some of the specific aspects of wireless IoT that support smart agriculture. I'm going to refer to this later, but this just gives you a feel for some of the differences across farming and across agriculture that need to be addressed. And there's different factors that need to kind of have different importances depending upon different types of farms and different aspects of farming. For example, when we think of a farm, we often think of half the state of Wyoming. Well, actually, small farms, and that's the definition of a small farm, is less than 5 acres, are really big globally. 5 out of 6 farms across the world are small, and you might think, oh, okay, but that's not very significant. It actually is, because even though they use only 12% of the farming land, they produce about a third of the world's food. A third of the world's food is produced by farms that are less than 5 acres. Family farms, now you might say, okay, small farms, that's probably somebody in a rural area who just farms in their backyard for their own subsistence. Actually, 9 out of 10 farms on the planet are family farms. Family farms combined produce about 80% of the world's food. So some family-owned farms are actually fairly significant in the whole agricultural market. Looking beyond that, indoor farming, which we can think of as being as simple as a greenhouse, indoor farming is also called controlled environment agriculture, is an established field, but it's actually growing quite a bit. Some of the advantages of indoor farming are that it produces year-round yields potentially. You can grow food where it's needed, so environmental conditions outside of the indoor farm aren't as big as a factor, and you don't have to transport food long distances. Conservation of resources. So, for example, an indoor farm can recycle water. Healthier and more abundant crops. So that's one of the big reasons to do controlled environment agriculture indoors, is because you can much better control the conditions and then get much more healthy and abundant results. Vertical farming is sometimes thought of as an aspect of indoor farming, where you can see that picture in there, we're taking farms and stacking them. So that's definitely a way to quickly multiply the output of a certain surface area of land, is to stack things on it. You can envision that kind of implementation that would have lots of sensors to monitor things like humidity, fertilization, temperature, plant health, soil condition. Lots of potential for high automation in an indoor farm, so lots of activity in a small area can reduce labor costs. Lots of focus with indoor farms on efficiency and yield optimization versus cost. So higher efficiency, higher yield, and lower cost. There's an advantage to indoor farms in that you can have a lot more control over the environment, and then again, a lot more control over the yield and efficiencies. There's also disadvantages that an indoor farm is going to cost more than an outdoor farm. As just one example, in an indoor vertical farm, you can have lots of efficiencies of water use. You can recycle water. Something like 70% of the fresh water on the planet goes into farming. So being able to recycle all of the water is a huge positive. Uh, Keep in mind, though, relative to an outdoor farm that might just use rain for watering. So there's lots less control in that, but rain is free. In an indoor farm, when you have recycled water, that means every single drop of water that goes into that farm and gets recycled is processed. That's a much higher cost. I've seen some indoor farms, vertical farms, that look promising and interesting that are doing okay. I've also seen some that look promising and interesting that failed. So I think a lot of the as you go down this chart on the left and some of these different types of farms and get closer to the bottom, some of those newer types of farms, in addition to kind of working out the technology, are still working out the business model of how they can be most effective in today's world. But the key here is all of these types of farms are going to be key going forward to growing our agriculture output. Wireless IoT, as I mentioned, can address all of the different challenges with all of these different types of farms. Some of the use cases for IoT and smart agriculture: directly monitoring crops. So that can be as complex or as intricate as looking at the color of a plant to determine if the plant's as healthy as that particular plant should be. That could be more broadly monitoring growth and things like that of plants. It can be weather monitoring, climate monitoring, soil monitoring. So I can monitor nutrients and moisture levels in the soil, which brings us to smart irrigation, which is actually one of the big applications today for IoT and smart agriculture. Smart irrigation can include pump control, moisture level monitoring, monitoring of the water depth and water content and water health in reservoirs. Smart building and equipment management, which starts to look a lot like industrial IoT. Livestock monitoring and tracking. As I said, livestock are kind of looped in under agriculture, and monitoring the health of livestock and the location of livestock can be a key application for wireless IoT. Drone farming, and you can see a couple examples of drones there on the left, which are smaller drones, which can be used for observation. They can be used in some cases to spray. They can be used in some cases to distribute chemicals or do kind of traveling remote sensing. Or you can see that big machine at the right. I was at CES a couple years ago, and I think it was John Deere had some massive booth that was completely taken up by the length of a fertilizer machine that very, very accurately sprayed fertilizer. So it was across a huge swatch of land that it would travel over. So it could much more accurately distribute fertilizer instead of just kind of spraying it everywhere, and see a lot of benefits and efficiencies from resources and labor resources when it was automated from that type of implementation. When we look across wireless IoT and smart agriculture and some of the wireless protocols, listed here are some of the protocols we see and some we could see more of going forward. Cellular IoT, so for those of you familiar with that, cellular IoT is cellular protocols that were released several years ago that specifically support Internet of Things type applications. They're lower power, lower data rate, lower latency. So protocols like LTE-M and NB-IoT, protocols like LoRa or other sub-gigahertz protocols, Bluetooth Low Energy Mesh, Thread, which is more often an industrial IoT protocol, but we do see a lot of similarities between smart agriculture and industrial IoT in terms of wireless protocols, and Matter, which is a newer protocol that encompasses actually some of the protocols listed there. Larger sensor implementations across a farm might need an infrastructure. For example, if I've got Bluetooth Low Energy or LoRa, I might need a base station, a gateway, an anchor to collect data from a bunch of sensors. Smaller implementations, where I'll only have a few sensors across a whole farm, whether the farm is small or it's just kind of newer in adopting smart ag and wireless IoT, might be more likely to use cellular, where it's just easier to have a direct connection from a sensor to the cloud. I'm going to compare some of these protocols and talk about some of the advantages, disadvantages, and smart ag implementations, um, and show you some of the different applications where they might be used. Some of the key factors as we do that are certainly energy efficiency. If there's a device out on a farm, quite often it's likely to be either battery powered or solar powered with a battery in it. So power consumption is going to be a huge factor. Coverage. So I might have small farms that might not take up a whole lot of area, but I might have farms that actually do take up a significant part of Wyoming, and I need lots of coverage, either through lots of nodes or longer range between nodes. So there's lots of variability in that across all of these different types farms I mentioned. Scalability. So if I'm going to produce a system that will function on a farm, I want it to work in a small farm and ideally have that same system easily applied to a big farm. Or if I'm a farmer and I start with just a small area where I'm implementing a system that includes wireless IoT, I want to be able to easily expand that to the whole farm. And cost. Cost is always a factor, especially in farms. We'll talk a bit more about that later. Because the smart ag market is new and still getting established, some of the protocols that we see today may not be used longer term. And I'll mention some of those that I've seen used, but may not necessarily be the best choice longer term. The flip side of that is there's some newer protocols that I'll also talk about that are just emerging and aren't out there because they're new, but they could have lots of advantages going forward and lots of good growth potential in smart ag. So comparing some of these protocols here based on power consumption, coverage, and scalability, three factors I mentioned in that last slide. There's shorter range protocols, and if you're familiar with Nordic, as I mentioned early on, we kind of built some of our market establishment based on shorter range protocols like Bluetooth Low Energy. Bluetooth Low Energy is a very low power protocol. A lot of these short range protocols can provide really low power consumption. So there's an advantage in terms of cost and power consumption. The range can be a disadvantage if you want to cover a bunch of area. Also, kind of positioning and how you use it is something to take into account, especially at 2.4 gigahertz, when there's going to be attenuation with water, and plants and soil certainly have lots of water in them that would attenuate that signal. We have seen these protocols used, and we expect to see them used a lot going forward, where you need a high density of sensors. For example, in vertical farming, where you'll have a lot of sensors in a small area, or you might monitor processing machinery. Might see them on small farms, and again, indoor and vertical farms. I have seen, and you see, again, with coverage with short range, the coverage won't be as long, but they can be very easily scalable depending upon what protocol you're using. Bluetooth Low Energy, for example, with mesh, is a very easily scalable protocol. LoRa or other sub-gigahertz protocols aren't as good for power consumption. They are good for coverage. They have a really long range because of sub-gigahertz. Sub-gigahertz has a good traveling distance. They can be easily scalable, but it just depends on how big the farm is. So as you might run into scalability limitations as you deploy more of these. So again, a long range between nodes. We have seen limitations and seen folks in Smart Ag concerned about limitations in data rate, not that they're trying to send video, but even just trying to send photos. Limitations in data rate with some of these sub-gigahertz protocols like LoRa, and some cost issues. We have seen them a lot, mainly because they're very easily accessible and there is an inherent range advantage to these protocols. So it's easy as folks decide they need wireless IoT in their systems that they're going to build, it's easy to go grab LoRa and use that. But we have seen some of those same folks come back and say, do you have something that's got a little more bandwidth that's more easily scalable? And cellular, we've seen a lot of cellular, which isn't great for power consumption. It's certainly better with LTE-M and NB-IoT that were specifically developed to be low power protocols. There's really good coverage with cellular when you have cellular. There's no infrastructure required because the cellular carriers own the infrastructure. The downside to all that is some farms might be small enough that they don't hit cellular coverage because they're in rural areas, or some parts of big farms might have adequate cellular coverage because, again, they're in rural areas. The other disadvantage of deploying cellular on every sensor is then you're paying a carrier fee basically for each of those. So we've seen those used, though, and I think we'll continue to see them used where there are a small number of sensors needed. where the sensors might be remote and wouldn't necessarily hook into another network very easily. Also see them used a lot in gateways in gateways for infrastructure. We have seen them again where you don't need a lot of sensors in situations like monitoring storage tank levels, or we are monitoring a reservoir level. A couple others I'll just say, as mentioned, as honorable mention. I have seen some Wi-Fi used in smart agriculture. Again, I think that's more a product of it's easy to grab and easy to use. For deployment, though, more broadly in farms, I'm not sure that's going to be the best solution because I think there's some other solutions that provide more advantages as you start to look at some of the characteristics of Wi-Fi. Bluetooth LE long range is something I'll also mention because you can get an increase in range with Bluetooth Low Energy long range. Roughly, a lot of it depends on conditions, obviously, but it's roughly a 4x-ish improvement in range. Lower data rate, but longer range. So as you're concerned about attenuation or things like that in vertical farms, we do actually have a couple customers who are looking to using Bluetooth Low Energy long range. It's not going to cover a whole farm, but it'll better cover an area of a farm where you might want to have a higher density of sensors. So I'm
And
going to talk about a couple
Clay,
newer. Yeah,
you have a couple use case questions in the chat if you would like to address either of those.
let
You know.
me see if I can figure out how to look at that. Yes. Decked NR Plus, yes. So I'm going to definitely talk about Decked NR Plus. Here, you're a good straight man, because that is literally on my next slide. Oh, go Illini, yes. How about that football team? Generalizations on the types of comms used for massive Illinois farms versus what you see in vertical farms. Generally 600 plus acre farms using cell, BLE, LoRa, et cetera. I would think when you get to farms that are hundreds of acres, you probably won't see a lot of BLE that covers the whole farm. You might still see BLE that covers small areas if you need more dense monitoring. I would think those types of farms are going to be more likely to use cell or LoRa. Or going forward, to the point of the next question, Decked NR Plus, where you'll just inherently have more range that you would need as you start to get into farms that are hundreds of acres or bigger. And again, good question, because the next slide actually starts to mention Decked NR Plus. Nordic supports Decked NR Plus and now what we call non-terrestrial networks. And I have a couple slides that talk about both of those after this. Neither of those are broadly deployed today. Decked NR Plus is new. NTN, which is what the short word is for short term is for non-terrestrial networks. NTN is newer in terms of its application to some of these use cases. Decked NR Plus is sort of a version of LoRa in that it's a version of LoRa. It's 1.9 gigahertz. And again, I'll get into more of that in a second, but it's got some inherent advantages over anything we see today. It's also long range between nodes, but it's an inherently mesh protocol. Cost per node is going to be higher compared to short range. But again, Decked NR Plus is actually similar to BLE in terms of it being a mesh network, but it can expand over hundreds or thousands or hundreds of thousands of acres of farmland. So it's very easily scalable across a whole farm. NTN, non-terrestrial networks, basically is a way to give you coverage anywhere with satellite. And as going forward, there'll be hookups between some of these NTN solutions and cellular solutions. So there'll be an easy trade-off, an easy handoff there from NTN to cellular. The next two slides actually talk just quickly about those in a little bit more detail. Decked NR Plus, it functions at 1.9 gigahertz. It's actually the only non-cellular part of the 5G suite of standards. Some of you might be familiar with the old decked cordless phones that were 1.9 gigahertz. The only similarity between this and that is the frequency band, 1.9 gigahertz. Basically is repurposing that band to this potentially massive mesh network. When I say massive mesh network, say that 3 times fast. Literally, you look at densities like 1 million nodes per square kilometer. Now, you might not ever need that, but again, that's scalable up to something like that is a pretty sophisticated and scalable mesh network. ranges between nodes of beyond 2 kilometers. And again, higher bandwidth than what we see from some of the 900 megahertz protocols today, so up to 3 megabits per second bandwidth. And depending on the implementation, low latency. So we don't necessarily need that in farming implementations. We might if we're doing drone control and things like that. Low latency is more typically for audio applications, which is another use case for DECT-NR+. It's license exempt in most regions. So it's basically a way to kind of establish your own private 5G network. And part of the security of DECT-NR+ is you can have multiple networks overlapping each other, and they're very secure and they don't talk to each other. So lots of advantages to DECT-NR+, especially when you're looking across farms, broad geographical areas where you need coverage and scalability. DECT-NR+ is a great solution. Non-terrestrial networks is a emerging phrase and an emerging technology. Satellite-based 3GPP systems, so cellular-like, but they extend terrestrial cellular services over broader areas. So you might have heard Iridium, which I'll mention this announcement later on. Companies like Starlink, Satellite, Skylo, several other ones. So they'll support regions and areas that might be outside terrestrial LTE coverage. So for areas where you don't have roaming or areas that just aren't covered, NTN can be a great solution. We've heard lots of customers as we talk about some of the cellular protocols, so the cellular IoT protocols, LTE-M and NB-IoT being deployed globally, having concerns about places like Africa is the kind of the big glaring one, where there isn't good coverage for those cellular IoT protocols, and they still rely on 3G, but now 2G, because 3G has been sunsetted more quickly than 2G. So they still rely on backup from 3G and 2G, but 2G has continued to be sunsetted. So NTN is a great solution for them because NTN would literally have global coverage. And because of that, has great applications in smart ag, utility infrastructure, environmental monitoring. Asset tracking is another area where we see lots of interest in NTN. We will actually we announced, and specific to NTN, Nordic just announced 2 weeks ago, support for NTN non-terrestrial networks on our cellular IoT system on chip solution, system and package solution, the NRF91, that supports LTE-M and NB-IoT and GNSS today. Going forward, next year, it'll support NTN, and we just announced support for Iridium NTN Direct next year, as that service is developed and comes online by the end of next year. So again, NTN is a great solution for smart ag, for areas where coverage might be an issue. Some of the challenges. Sorry, question?
Oh, yes. We had one question in the chat about Detect NR+. So if someone wants to play with Detect NR and its features, how many devices or nodes would they need to own?
To play with the features?
Yes.
Well, if you want to play with the mesh aspect, then you would need multiple nodes, but you can mesh 2 or 3 devices together. We actually have a smart ag consortium that we're a part of, and a university that's in that consortium who has students that have 2 or 3 of our devices and are looking at right now how they might connect those and how the DECT-NR+ mesh might work in that in the environment that they're looking at. They actually were also looking for a solution that was more scalable and had a little more bandwidth than LoRa.
Mm-hmm. Awesome.
So you mentioned Wirepass. Yeah, Wirepass is a partner of ours. As we work with DECT-NR+, we have a couple partners. Wirepass, focusing on the massive mesh implementation side of that. Wirepass is really good at that. And we have another partner called Link Networks, who has a couple different aspects to their DECT-NR+ deployment. One is that massive mesh network focused on audio, and another was just a telematics deployment focused more on applications like this. So we have some options for going forward with for partners that we can connect folks with to specifically look at some of these DECT-NR+ applications. Some of the challenges with another question.
I know. Thanks, Clay.
Sure. So yeah, and by the way, if you have questions that I don't have time to answer or that I can't answer, as these slides are sent out, I will try to include those as kind of an addendum in the slides as everyone gets these, so you can see that when you see the slides. Some of the challenges of wireless IoT, farms don't always have adequate internet connectivity because of the location of the farm. They may not have good coverage in part or all of the farm. As we talk about some of these different applications, you can see that again, like when you're looking at connecting machinery together, I might use a different IoT protocol than I would use in other aspects of the farm. So those are two different systems. How do they work together? Because ideally you have one platform that manages everything. So just the interoperability between some of the different systems and protocols. Scalability, I mentioned, is becoming a bigger and bigger issue. So you don't have to reconstruct a new architecture for every different implementation. Cost is huge, and I'll talk about cost a bit later on as being a barrier for some types of farms. The other issue is the lack of awareness of technology. I mean, I talk about this as a silicon provider, and Nordic, I think, does a really good job as a silicon SoC provider of wrapping lots of resources around what we have. So even though at the end of the day, we are a chip company, we have lots of resources in terms of development kits, software, platforms. We have our cloud services, lots of different things that can bring that together into a more complete solution. But still, a farmer is not going to call Nordic up typically and say, "Hey, I want you to tell me about Deck Denner Plus on my farm." A farmer's going to not probably know where to go to get that. So a big challenge as Nordic looks to drive some of these different use cases and applications is that whole ecosystem of how Nordic's technology gets adopted and actually gets into systems that then can be easily accessible to farmers. I do have some other aspects to that we might get to discuss, but I think there's some consortiums and some other groups that Nordic has actively searched out and is actively a part of to help drive that adoption and the creation of that whole ecosystem. As an example, and again, I mentioned one of the issues is the interoperability of different systems across a farm, different IoT systems and different applications and different use cases. I think Nordic is in quite a good spot to support smart agriculture, and part of that is part of the basis for that is just the breadth and the types of solutions that Nordic has. As an example, again, farms can range from small to large. One of the technologies that we just talked about is Deck Denner Plus that allows scalability, a massive mesh network that can cover anywhere from a few acres to thousands of acres. So with that, it's a very easily scalable system that basically gives you nodes all across the whole farm that you can hook into with other Deck Denner Plus enabled devices. You might have need in certain places for more dense monitoring, whether you might have a greenhouse, for example, where you might more dense monitoring, or maybe just because of the nature of the crops, you want to monitor them more closely together. Grain silos that might be next to each other. With that, you can incorporate a shorter range network, like something based on BLE in those areas that would still hook into the Deck Denner Plus network and send that data through from the shorter range implementation to the whole massive mesh network across the farm to get out to the cloud. Or if you have areas of the farm you just want to monitor kind of independently, you've got cellular IoT with NB-IoT or LTE-M, or as I mentioned, non-terrestrial network, so you can hook into a satellite and then go up to the cloud. And with that, you've got a system where you have access to all of these different sensors across all of your farm, across any size farm, and be able to take that data into the cloud and have a system that analyzes it and tells the farmer what to do, or gives the farmer the data so the farmer can make his own decisions. Nordic actually also, as we look at how to implement these in a device, Nordic has developed over the years power management capabilities. So as we're making devices that are, again, ideally low power, just because of the nature of the implementation, Nordic can help those be even more optimized to low power with some of our power management solutions. And like I said, the value really here is lots of different solutions, but also taking those different solutions to create hybrid solutions that can easily combine advantages of multiple wireless protocols across the whole farm and across the whole farm ecosystem. Looking at how our portfolio at Nordic might support this. As I mentioned, Nordic's got a history of with short range SoCs that support Bluetooth Low Energy and some other protocols. We started actually in 2010 with our NRF51 series. In 2015, our NRF52 series came out, which is an ARM Cortex M4 based series of chips, and I think there's 6 or 7 or 8 chips in that SoCs in that family. A few years later, we had the NRF53, which is dual core, so we added dual core capability and moved up to the newer M33 Cortex ARM M33. As you might guess, the next series is coincidentally named the NRF54 series, which comes out this year. We've actually had it sampling for almost a year now, so that we've worked out a few of the initial issues, and we'll be releasing into production by the end of this year. And we have kind of 2 different levels of that we're starting with, a few versions actually of the L series, L standing for low, which is more more designed around simpler implementations. We've continued to improve power consumption as we've gone through our progressively enhanced series of Nordic low short-range SoCs. So we have another improvement with process and with power consumption on this newer series with a single core NRF54 and then a multi-core NRF54. So that's actually going to have 2 M33 cores and then a few different RISC-V cores for some simpler functions like peripheral management. And again, so there's lots more information about those on our website. There's a bit more information here. Again, there's with the protocols we support, Bluetooth Low Energy, Matter Thread, ANT is an old protocol that Nordic continues to be one of the few who supports that. We've got more efficiency, lower power consumption on this. We've moved to a 22 nanometer process, which is part of that lower power consumption. We've continued to improve upon security services and adopt some of the newer security standards that these chips reflect. And again, we've continued to improve on the radio and the performance. I won't walk through these, but you can see here at a super high level some of the performance or features of both of these and some of the differences between the two. We actually have a few different flavors of memory configurations of the NRF54L for folks who might need less memory than this. And again, there's some high-level features here. You can go to our website, or we can talk further after this if you reach out about some of the more detailed details of the features. Targeted applications, the one that's important to this particular presentation is the one at the end, which is Smart Ag. So again, the 54L we might see in simpler sensors, more edge applications. The NRF54H we might see in complex sensors or in something that might be more of a gateway type application or a central node anchor type application. Nordic has a very comprehensive software development kit we call NCS or NRF Connect that we launched a few years ago that encompasses all of our different SoCs. So it's a single platform that will support our short-range devices, NRF52, 53, 54. And the other one I'm going to talk about in a second, that's our NRF91 longer-range device that is cellular IoT, DECT, NR+, and NTN. It's based on the Zephyr RTOS, so it gives you a whole lot more control over more of an event-driven type implementation. As a side note, I mentioned power management. That's one of the complementary ICs that Nordic has released. It's not necessarily a newer technology for us because we've had power management as a part of our SoCs for a long time. We just sort of broke it out a few years ago because we found more and more folks looking for power management ICs and looking for lower power applications that we can help optimize by doing this with our power management ICs. So that's one of the few offerings we have today with that NPM 1300. We have partners that we've worked with historically for front-end modules, and because we had more and more folks interested in that, again, to kind of optimize the ecosystem and minimize power consumption, we developed our own front-end RF module that includes a power amplifier and an LNA that also supports antenna diversity. So if you need even more range, this is a way to extend, especially in a smart ag implementation, where it might be more critical, way to extend the range of protocols like Bluetooth Low Energy. I mentioned early on that we released a Wi-Fi solution. Now, there's lots of Wi-Fi providers out there. Nordic is not looking to compete with the world in Wi-Fi, but we are looking to add IoT Wi-Fi capabilities to our portfolio, and that's what this chip does. This solution does. It supports Wi-Fi 6 at 2.4 and 5 gigahertz. Lots of different advantages, but again, think relatively lower data rates. It's still a pretty decent data rate with 86 megabits per second, and low power consumption. Two things that Nordic supports real good with IoT is what we get with our NRF70 series. It's a companion chip to our NRF 53, 54 series and our NRF91 series. I mentioned these chips. You can see just a little bit on the evolution of this. We launched the first one almost 6 years ago now. It's been in development for a long time. Today we have our NRF51 that supports LTE-M, NB-IoT, GNSS, DECT Plus, and going forward NTN. Lots of components in this, and it's an integrated system in a package. So there's also a front-end module and power management integrated into this system in package. I mentioned integration. You might see traditionally some of these various modules in a cellular solution. Nordic takes that and integrates the whole thing into our SoC and into the system in package. Again, I won't go through this other than to say it's a dual core architecture. Low power is what Nordic's all about. So we have some low power hooks in here relative to cellular IoT. I will mention that this NRF91, for those of you that are interested in the US, has a non-China country of origin, which basically makes it tariff-free in the US. And then we also, like with all of our chips, have various versions of development kits. We have a platform called a Thingy that is basically a multi-sensor development platform that includes the NRF91, 9151. It includes one of our BLE SoCs. It includes Wi-Fi and lots of sensors in it. So it makes it a great tool for sensor prototyping and lots of different applications that are sensor driven. Mentioned our NRF Cloud. That includes location services that enhance the GNSS capability of the NRF91. Also now includes some security services and device management solutions. These are just a few quick examples of where we've seen Nordic today in smart agriculture. And again, these are just a few. These are all publicly announced. There's lots of other ones that aren't publicly announced, so they're not included here. Irrigation and monitoring and control has been a big initial smart ag application. There's lots of LED lighting applications that we've seen. Environmental monitoring, and this can be for indoor vertical farming. We started to see become bigger as those use cases have become bigger. Lots of applications in livestock monitoring and tracking, and then in gateways where people might want to distribute sensors for various reasons that might be BLE based. We've seen our NRF91 and one of our NRF 52, 53 series SoCs. Just as a quick summary, today we're seeing a lot of applications that are smart irrigation focused. That's probably been the biggest application we've seen today, but so that could be control and monitoring for pumps, moisture level reservoirs. Also seen, as I mentioned, some livestock monitoring and tracking applications. Seen lots of startups and smaller companies. As I've been to trade shows and engaged with customers, I've seen a lot of those just kind of doing niche-y things that are really interesting and really needed. A lot of times we've seen a wireless protocol that's not necessarily strategically chosen, mainly because folks are looking to deploy something to solve a specific use case problem and not looking at some of the broader issues that I mentioned, interoperability and scalability across a whole farm. We've also started to see some of the higher density sensor applications. We've seen more long range because it's easy, and that typically has been cellular, where there's been fewer nodes, LoRa or sub gigahertz, where people want to have more than a few nodes, but not necessarily a lot of nodes. And basically, longer range looks like an extension of industrial wireless IoT. In the future, we think we'll see a whole lot more short range as dense monitoring becomes more of a requirement. We think longer range will need to support flexibility for different applications, environments, and farm sizes. I've seen folks talk about AI and cloud connectivity a whole lot more so that the tools are more easily useful for farmers and growers. Scalability and low power continue to be a key across all of this. And again, there is a need for smart ag to support complete ecosystems with different implementations. So it's easy for farmers and growers to take advantage of some of these features that they really need to be more efficient in their whole process and in their whole approach to agriculture. As a last slide, people might ask, as a chip company, why do you care so much about driving smart ag? I think we have to care. Nordic is very environmentally conscious, which is a fun aspect of the company. We need to better feed an increasing population, and enable a more efficient and more environmentally practical use of land. Again, Nordic chooses to pursue markets that can positively impact the world. We're a publicly traded company, but Nordic really likes to have a positive impact on the world, in addition to providing a return to our shareholders. So Nordic chooses to focus on environmental sustainability and governmental type issues because we can. We have a good broad technology and a good market position to support specifically this other markets, but specifically this market. So as this is a growing market, we're very interested in taking advantage of the opportunity to positively contribute to this industry and ideally to the future of the planet. And with that, I am done with the body of the presentation and happy to take any questions.
Awesome. Well, first and foremost, thank you so much, Clay. We do have a couple more questions coming your way. Um, so Detect NR plus NB-IoT, NTN, they all exist on the same chip simultaneously on a shared complex or shared multiplex scenario?
To clarify, good, that's a great question. So today it's LTE-M and NB-IoT, but only one of those would operate at a time. So today it's also LTE-M, NB-IoT, or DECT NR Plus. Now it's theoretically possible to reflash the chip with an external memory, reflash the NRF9151 from external memory, and enable DECT NR Plus versus LTE-M and NB-IoT. But again, today those don't coexist on the same with the same modem firmware implementation. Those are two different firmwares.
All right. And how do you protect the sensors, electronics, and assets from theft or vandalization?
Good question. There's a lot of that might come down to more of a mechanical issue. In terms of security, the portion of that Nordic could affect, other than just asset tracking. So if it walks away for whatever reason, you can track it. Nordic's side of that would come down to security of the RF, and there's a whole lot of resources on our website that talk to, again, some of our newer chips in particular support some of the newer security certifications that are really good at ensuring that from an RF standpoint, the chips are very secure.
Thank you. And how about machine learning in smart agriculture using Nordic devices?
Yeah, good call. So again, we've seen lots of AI implementations. Those are often more back-end, more AI within the platform. Nordic, though, acquired a company a couple years ago to implement machine learning at the chip level, at the edge level, for some lower level functions. So as we develop newer solutions beyond the NRF 53 and 54, we'll start implementing more and more ML capabilities within the chip. We actually do, though, today have a partnership with a company called Edge Impulse that provides some machine learning capabilities that are looped into a part of our SDK. So we have some of that capability today, and we're looking to roll out more and more of it going forward as part of the hardware and the chips.
Thank you. All right. And as a reminder, if you have questions, the Q&A is open, as is, you can also put it in the chat. We have a couple minutes left, so here are a couple more questions. Are some geographies more or less active in adopting smart ag solutions?
Yeah, that's a really good question too. We've seen activity more and more across the world. I mean, historically, the US and Europe, Western Europe, have been big in developing and adopting some of those. But even across the US, there's just different growing environments California is a real interesting growing environment because you can get 3 or 4 growing seasons out of a year. The Midwest, the breadbasket to the world, where we grow lots in cornfields, really only has one growing season of the year. Um, California grows a lot of specialty crops, does a lot of crop rotation even across the course of a year. The Midwest grows corn, so their crops are not quite as specialized, lower margin. Interesting thing there is a lot of cases we've seen more interest, or the industry has seen more interest from farmers in the Midwest, where they have lower margin crops because they're much more active in squeezing pennies or tenths of pennies out of everything that they can in order to increase their margin. So we've seen more interest there in some of the smart ag implementations. We have seen a lot of the smart ag companies located where the agriculture is. So for example, in California, there's a lot of smart ag companies. In Midwest, I've seen more smart ag companies focused on some of the specific issues with that area. And the same thing in Europe. So there has been some variation across regions based on what happens in that particular region, but more and more we're seeing activity in more regions across the world.
Awesome. And are there any, or what are the barriers to adoption of the solutions that IoT can bring to agriculture? I know you've talked about, Wi-Fi and availability, but
Right, at a high level, the ecosystem, again, because as a farmer, like I said, a significant part of the food grown in the world is grown on small farms, smart farms less than 5 acres, and farmers like that, there's not a lot of revenue, there's not a lot of margin, and it's going to be hard for someone like that to have access necessarily to a lot of what I just talked about. So a big part is the ecosystem and developing the ecosystem. One of the ways farmers use outside resources is in how they fertilize their crops. Most farmers today, some farmers might be more apt to use someone's analysis of their farm to determine what they want to do and how they want to treat their crops. Some might just be more apt to go on decades or generations of family experience. But in either case, most farms at some level use an outside service for fertilizer. And fertilizer is not the same for every farm. It depends a lot, obviously, on the crops you're growing, but also on the region you're growing in, and even on the condition of your soil in any given year. So the way farmers today most farmers have access to technology is using some of these outside services to provide chemicals to ensure healthy crops. So with that, you can start to envision some of these companies that provide that service, looking more to companies that can make hardware ecosystems and software ecosystems to structure more services around what they provide. And then instead of just saying, well, I got a soil sample and here's what you'd use, they should say, hey, by the way, Farmer Brown, today you need more water. So we'll flick on the water, or we'll tell you that and you can turn the water on.
that makes a lot of sense. And this is probably going to be our last question. But you said California was at the forefront, I believe, within smart ag. So, what are the main crops being grown using smart ag technology?
Well, that's a great question. I mean, avocados are something that are grown in California and Mexico. Avocados are weird. I was talking to a guy who does smart ag for avocado farms. He just likes to focus on avocado farms. But avocados need dry climates, but obviously you can't have climates lacking in any moisture. So it's a very certain amount of moisture that turns out California can easily provide. They need to grow on a hill and have like a certain angle of the sun. So it's very specific in terms of where you can grow them, not just geographically, but kind of the terrain and the angle of the land. So, I mean, water is wildly important to successful and thriving avocado crops. So that's one of the places where smart irrigation makes a whole lot of sense. And I've seen 2 or 3 companies in California focusing on smart irrigation specifically to their avocado crops in California and Mexico.
Well, thank you. With that, we will conclude our Smart Ag webinar with Nordic and Clay. Thank you so much, Clay, for being here today and answering all of our questions. Was there anything else that you'd like to share with anyone? Anywhere that they can reach out to you or Nordic if they have more questions?
Yeah, go to our website, nordicsemi.com. On the front page of this is my phone number. Please don't put it all over social media, but share it within your companies, or feel free to reach out if you have any questions. My email address is there too. So just reach out to me about any of these. I can't guarantee that I can answer all your questions, but I can certainly find someone who can answer your question. And if you have, as you have applications and implementations, let me know. We have lots of partners. I mentioned a couple of them, but Nordic, on our website, you can find our partner program with design partners or solution partners who provide kind of companion aspects to what we do. And we're happy to pull any of those in as needed for whatever you want to do. But I appreciate the time. Thanks everyone for logging on and listening, and happy to chat with any of you. Hope to see you out and about in the technology world.